So today we are going to discuss on a new course of metallurgy and material science. Metallurgy and material science is a very important subject because if there is no material, nothing will work. There comes the importance of study of metallurgy and material science. So let's have a look into the syllabus of this material science course offered by most of the Indian universities. In this case, we take the syllabus followed by Cochin University of Science and Technology. So it consisting of 4 modules. The first module says it gives a general idea on crystallography, crystal structure, surface lattice, crystal systems, Miller indices, crystal planes and directions, atomic density, the atomic packing factor, coordination number, etc. That all portions we covered in the plus 2 classes. Then comes the portion of solidification of metals. The solidifications are of different types, the homogeneous nucleation and heterogeneous nucleations. So the process of solidification is not so complicated, but it is so important when we are considering some of the manufacturing process or when some metal producing process like casting, etc. So homogeneous and heterogeneous nucleation. Crystal growth, grain and grain boundaries. The orientation of the grains, so the defects of the grains will help us to study about the properties of the materials, etc. So then the crystal imperfections. Imperfections are good in some cases and bad in most of the cases. So imperfections will cause changes in the structure. The changes in the structure will change the properties of the materials. An understanding of imperfections is very necessary for the study of the course of material science. In this course, we will study about the different types of defects such as point defects, line defects, edge dislocation, screw dislocation, etc. And the last portion is diffusion, the process of diffusion or the mechanism of diffusion in crystals and types of diffusion, factors affecting diffusions, the laws governing the diffusion, and the application of diffusions are covered in the first module. And the second module, the phases, the different phases, as we know, when any matter exists in different phases. So when we are dealing with the materials will exist in different phases. So the Gibbs phase rule, solid solutions, etc. are studied. And interstitials and substitution, types of solid solution, different types of solid solutions are covered. The Hume-Rothery's rule for there are 4 or 5 types of rules, so that will helps you to study easily about the process of a solid solution or the existence of solid solution. The equilibrium phase diagrams, the binary alloys, as well as we have to study some of the examples like copper-nickel system, cadmium bismuth, lead zinc, iron carbon system, etc. So heat treatment of the steel is the second portion. Heat treatment is very important in order to reduce the residual stresses developed in the systems. For the complete understanding of the heat treatment, we have to study about the TTT diagram and the process of different heat treating processes such as annealing, normalizing, hardening, tempering, host tempering, mark tempering, hardenability of the steel, etc. And the test for the hardenability of the steel is the Germany test we have to study. The surface treatment, case hardening, carburizing, cyanide nitrating, flame hardening, induction hardening, metal coating, hot dipping, electroplating, electric metal cladding, impregnation, and metal spraying, etc. are covered in the second module. And the third module consisting of the study on basically the deformation and failure of metals. So we know that there is 2 types of deformations are there. One is elastic and plastic deformation. The mechanism of a slip or the mechanism of a plastic or elastic deformations are covered in this portions, and the process of work hardening, cold working, hot working, etc. are covered in this portion. And different types of temperature based and non-temperature dependent failures such as a creep, fatigue, etc. are studied in this third module. And the fourth module generally covers the different applications like application of non-ferrous or non-ferrous alloys such as different categories of steel, something like alloys of aluminum, copper, cast iron, magnesium, titanium, etc., and the refractory materials like ceramics, etc., and the study on the super alloys, composites, glasses, nanomaterials, biomaterials, and optical fibers are covered in this syllabus. Thank you.